Dot School presents Quadratic Equations 2. Recall that in a quadratic equation, the highest power or the exponent of the unknown is 2. In this video, we shall learn how to solve quadratic equations using the method of factoring. Your first job is to take out common factors, if any, between the coefficients of x squared, x, and the constant term. So if you have something like ax squared plus bx plus c is equal to 0, where a, b, and c are constant numbers and x is the unknown, you want to look at the values, the numerical values of a, b, and c, and try and figure out the greatest common factor, or the GCF. Let's use an example. Let's say we want to solve the equation 20x squared plus 52x plus 24 is equal to 0. Now, before we go on to factorize this expression, note that all these three numbers, 20 and 52 and 24, they are all even numbers, which means their common factor is 2. We can take out a 2 and then have the rest inside the parentheses. 2 times 10 is 20, therefore this is 10x squared plus 2 times 26 is 52 plus 26x plus 2 times 12 is 24 plus 12 is equal to 0. Now this is as good as saying 2 times all of this is 0. Now when can 2 times something be equal to 0? Obviously 2 is not 0. So it must be that this portion out here has to be equal to 0. Therefore, in the next step, we can just get rid of the 2. We don't need that anymore. We could just go ahead and say that 10x squared plus 26x plus 12 is equal to 0. And the idea of factorizing is that you want to split the term in x into two pieces, so that obviously they have to add up to positive 26, and the product of those numbers, something x plus or minus something x, the product has to be equal to this, which is 10x squared, times this, which is positive 12. That gives you 10 times 12 is 120x squared. You don't really need to take a look at the x squared. In any case, you're going to have an x squared. X times x will give you x squared. So let's focus on the numbers. We need to split up 26 or positive 26 into two pieces so that the product is positive 120. Now how can we get that? If you think carefully, you realize that in this case, we can make the split as a 20x plus a 6x. 20 plus 6 is 26, and then 20 times 6 is 120. So that works. So we have 10x squared plus 20x plus 6x, which is 26x, plus 12 is equal to 0. The idea is to pair them up and factorize each pair. Common factor between 10x squared and 20x is 10x. If you take a 10x from here, all you're left with is a x, plus if you take a 10x out of 20x, we have a 2, plus common factor between 6x plus 12 is 6. If you take a 6 out, you have a x, plus 6 times 2 is 12, we have a x plus 2 is equal to 0. Therefore 10x times x plus 2 plus 6 times x plus 2 is equal to 0. In the next step, we take the x plus 2 as a common factor out from the two terms. X plus 2 times 10x plus 6 is equal to 0. And this is what we were looking for. Our idea was to factorize the given expression. Something times something is equal to 0. Obviously, we could take the 2 out because 2 is never equal to 0. Now, either this is equal to 0. So there you go. You have the either-or situation. Either x plus 2 is equal to 0 or 10x plus 6 is equal to 0. The product will be 0 only when at least one of these two is equal to 0. When x plus 2 is equal to 0, we have x is equal to negative 2. And when 10x plus 6 is equal to 0, you take the 6 on the other side, you have 10x is equal to negative 6. You divide both sides with 10 and simplify that. You have x is equal to negative 6 over 10, which is equal to negative 3/5. So either x is going to be equal to negative 2 or x is going to be equal to negative 3/5 for all of this to be equal to 0. Let's look at another one. This time, let's say we have 9y cubed, or 9y raised to the third power, plus 15y raised to the second power, that's y squared, plus 6y is equal to 0. Now this doesn't look like a quadratic equation because the highest power of y, as you can see over here, is 3, it's not 2. But if you think about taking the common factor out from these three terms, 9, 15, 6, they're all multiples of 3. So we are going to say that, okay, 3 times, there's a y here, there's a y here, there's a y here. At least there's a y in each one of these. Therefore, 3y is a common factor, is equal to 0. Now, if you take a 3y out of 9y raised to the third, you're left with a 3. 3 times 3 is 9. Y raised to the second, y times y squared is y raised to the third, or y cubed. Plus, if you take a 3 out of 15, you have a 5. 3 times 5 is 15, times y. Y times y is y raised to the second. Plus, if you take a 3y from 6y, you have a 2. 3y times 2 is 6y. And we have a quadratic expression inside the parentheses, as you can see over here. Therefore, in the next step, we can say that either 3y is 0. Well, 3 is not 0. So therefore, either 3y is equal to 0, which means y can be equal to 0. Yes, that's a possibility. If y is 0, then all these three terms is equal to 0. If you add them up, 0 plus 0 plus 0, you get a 0. Or, now the or scenario gives you a quadratic equation. Or, 3y squared plus 5y plus 2 is equal to 0. So we have a quadratic equation. Split up the term in y into two pieces so that the sum is positive 5 and the product is 3 times positive 2, which is positive 6. And the only way we could do that is if we split it up as a 3y plus 2y. 3y plus 2y is 5y and 3 times 2 is 6. So we have 3y squared plus 3y plus 2y plus 2 is equal to 0, which means take the common factor out, pair them up. 3y times y, 3y times y is 3y squared, plus, if you take a 3y out of a 3y, you're left with a 1. 3y times 1 is 3y, plus, common factor between 2y and 2 is 2. If you take a 2 out of 2y, you're left with a y plus 2 times 1 is 2 is equal to 0. Therefore, y plus 1 is the common factor between these two terms. Let's take that out. Times what's left is a 3y from here plus 2. That's equal to 0. Now there's another either or in this one. Remember, this itself is a part of the or. The either side was y is equal to 0. And under the or, there's another either or. So we could say either y plus 1 is equal to 0. The product of these two can be equal to 0 only when either this is 0, y plus 1 is 0, which means y is equal to negative 1, or 3y plus 2 is equal to 0, which means you take the 2 on the other side, you have 3y is equal to negative 2, which means divide both sides with 3, we have y is equal to negative 2/3. So there are three answers: y is equal to 0, y is equal to -1, and y is equal to -2/3. And that's exactly what you would expect from an equation in which the highest power of the unknown is 3. You'd expect three answers. They may be same, they may be different. In this case, all three are different. This is exactly how you solve quadratic equations by factoring.